making this quick video as a recap on how to draw a graph from a given sequence or pattern. So sometimes the sequence or the pattern is given just as a list of numbers like it is here. Sometimes I might give it to you in like a drawing where you have to count up the dots or count up the matchsticks or something. Either way, you end up with a list of numbers, okay? So we always put it into a table first. In most questions on the papers, you're asked to do that. So it's not given in a table. Your first kind of 5 marks will be display this information in a table. So the table is pretty much always term number and term value. Now sometimes they might have another meaning, like, I don't know, it might be something like kilometre of driving and taxi fare, so the term number might have a significance as opposed to just being the first term, the second term. It might be like the first kilometre, the second kilometre, and so on. And then the term value, instead of just being a number, it might have a significance. So it might be like that 1 kilometre costs €4 and so on. Okay, so that's the difference between it being just a straightforward numbers question or whether they're going to add a problem dimension to it, okay? And you do have to be able to do both, and they're both in your book. So I think the second chapter, is it 32 or 31? The chapter that's near the end of the book, that kind of does more of the problem type questions. Whereas earlier on then we're doing the numbers type questions. One isn't any harder than the other, they're just slightly different, okay? So in every single one, whether it's a problem or it's not, you will have a term number and you will have a term value, okay? It's just that sometimes in the problems, these have different names, okay? So the term number means like the first term, the second term, the third term, and so on. So if we look at our sequence here, we have 1, 2, 3, 4 terms of the sequence. So we will have term number 1, term number 2, term number 3, and term number 4. Then the value of these terms. So term 1 has a value of 6. Term 2 has a value of 10. Term 3 is here with a value of 14. And term 4, then the last one, has a value of 18. Okay? Then we put these into our graph. Okay? So what's going on with my graph? Sorry, now I'll try and just close it and open it again and see what happens. It is not opening. Aha. Okay, the graph's back. Sorry about that. Okay, so the term number goes on the x-axis. You can see that here, x-axis. And the x is the one that goes across, term number, and then the term value here goes on the y-axis. Okay, so I need 4 entries on my x-axis. So I'm going to go 2 boxes. So 2 boxes aligned, 2 boxes aligned, 2 boxes aligned, 2 boxes aligned. So whatever jump you make with your first line, your first interval line, you must stay consistent with that. Okay, so I decided to go 2, so I have to keep going 2. Okay, now I'm just trying to do 1, 2, 3, 4. So the easiest thing to do is 1, 2, 3, 4. Okay, now on the y-axis I need to get to 18. So I'm not going to have enough space to actually just go 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 18. So you have to make a decision then. Do you go up in 2s or do you go up in 3s? So I think I'm going to go in 2s. And if I just go 1 box, okay? So you don't have to match your x-axis, it can be different. So I'm going to go 1 box and call that 2. Next box will be 4. Next box will be 6. Next is 8. Next is 10. Then 12, 14, 16, and 18. Okay, so I made a 1 box jump from my first box, so I had to be consistent with that. I also, from my first jump, I went up in 2 And once you decide what you're going up in, you have to stay with that. So I had to continue to go up in twos. Okay, I'll get rid of this in a minute, but let's say I do my axes, right, and I go 1 boxes. Okay, and let's say I go 3. First box is 3. I am now doing the 3 times tables. So it's 3, 6, 9, 12, 15. Okay, no other options there. If I take this out, let's say I decide that my first box is 5. I'm now doing the 5 times tables. 5, 10, 15, 20, 25. Okay, so you can't make different leaps. I wouldn't be, like, if I went 2, I am now committed to the 2 times tables. So I couldn't do 3, that would be wrong. It's not in the 2 times tables. Okay, so that's very important when it's called choosing a scale, choosing an appropriate scale. So when you choose your scale, the box in between the intervals, so in my y-axis I went with 1 box, or in my x I went with 2, that has to stay consistent all the way across. So if I decide on 2 box here, I have to stick with 2 boxes the whole way across. If I decide here with 1 box, I have to stick with 1 box. Okay? Right, so let's throw our numbers on. So the first term is 6. So I go to term number 1, I follow the line up until I get to 6, and then I put down my dot. Term number 2 is 10, so I go to term number 2, follow the line up, and get to 10. Term number 3 then is 14, and term number 4 is 18. Okay, so go to your term number, hold your line, and you're just basically following up here on the y-axis until you hit the term value. So term number 1 has a value of 6. Term number 2, follow it up, it has a value of 10. Term number 3, follow it up, has a value of 14, and term number 4 has a value of 18. Now, in terms of plotting the graph, that's pretty much it. I'm just going to go into a little bit of the detail. So you will notice that if you take a ruler, you'll be able to draw a line straight through all of your points. That is because this is a linear graph which was produced from a linear sequence. How do we know it's linear? We know it's linear because we know that this is a linear sequence because it should have a constant d. Constant d, okay, which is your first difference. So if I look over here, the jump here, d is 4 here, d is 4 here, d is 4. Okay, so it's constant, as in it's unchanging, 4, 4, 4, 4. That makes it linear. Okay, so when we drew this graph, we would expect to get a line, and we did. Okay, and the other thing that we would have learned when we were doing this was that the slope should be the same as d. So if you remember, you get the slope by doing the rise over the run. So you pick a point, and you pick another point. You join them with a triangle. No. The rise is going up the way. So this here, if I look across, is at 10. And this one here, if I look across, is at 18. So that is a rise of 18 minus 10, which is 8. And then the run, so the run starts here and you look down. So that's 2. And it goes to here, but you look down. So that's 4. So the run is 4 minus 2, which is 2. So if I go back over here, the rise is 8, the run is 2, giving me 4. And if you look, that's what the common difference was. Okay, so that's just a little bit of additional information about a linear graph. But in terms of plotting the graph, hopefully that makes sense. And then it shouldn't matter if the shape of the graph changes. The concept of plotting a graph is the same, whether the graph ends up in a straight line or not. Alright, so hopefully that helps with your study for Friday.